Good evening, everyone. Today we're going to talk about, in this series, the SnowPro Core exam guide. So we will go through the SnowPro Core exam study guide that is official by Snowflake, and we will take topic by topic and we will start explain them in this series. And we will start today with domain number 1, which is talk about the Snowflake data cloud feature and architect. Today we will go for the first part, which talk about the layers and component of Snowflake. So let's start by 1.1. In that part, we will speak about the architect foundations for Snowflake. Let's take a quick back look in the history of the database and data management so we can get little feeling of how this three-layer new model solves the main challenge that faced before. So the legacy is like, of course, the on-premises. It not means that it's not being used right now. Actually, a lot of governments and a lot of organizations that manage a sensitive data, especially some places like our organization, same like for example the banks, they are by the law sometimes in a specific country they are not allowed to use a cloud and they need to use on-premises solution. What is the challenge on on-premises? You are managing the server, you are managing the hardware itself, and we call it like capacity extension problem. So you need always to reinvest in the scalability, and that of course cost a lot of money because you need to scrap the old stuff, buy new stuff, and most of the time the old stuff, even if you sold it back, it will be for a fraction of the price you got it. So the aim from this Snowflake modern architect is to solve two main issues, and you need to remember this for the exam: concurrency and scalability. We need to find a solution that allow us to make the scale, to upgrade the scale without the need to invest a lot. At the same time, allow us to do the concurrency. It means more than requests will go parallel at the same time with no issues. Then came the second step, and we start use the shared disk. So we have a central location, and many companies or many departments are using the same data base in the background. The problem was like we solved the problem of hardware to be managed internally, but we're facing a new problem, which is like bottleneck. When we have too much requests on this shared disk, always it have too much problem with slow, or it actually sometimes even get down. Then it came the age of the cloud, something like Redshift, for example, from Amazon, from AWS. You start build isolated disk that allow that we save the data in the cloud. So we solve the problem of the capacity, we solve the problem of scalability, but we have a problem of sharing the data. So there is no anymore the problem of concurrency, because like they are now like different versions. They are also managed to meet the different requirement of each department. But for example, I have the same data that I need to use for finance and HR, another sister company. They will be all in a different locations because it's like isolated. Is that the perfect solution? Of course not. So what was the new modern architect? Snowflake came with three-layer solution that allows the concurrency and the scalability. It's like based the whole solution based on cloud platforms. So it's like a management for the data through the cloud. So what is this three-layer solution? First, we have the storage layer. So you need to store the data in somewhere. Before you used to store it in the hardware on premises, in the shared disk, and here we store it directly in the cloud. So consider the platform of Snowflake is on the top, and you have down container. You want to put your data as a pools. So your data, your pools will go in different solution. It can go into like Amazon S3 bucket, it can go into Google, or it can go into Microsoft Azure product. That create for us the centralized repository. So we have this kind of like shared disk, but at the same time, it's limitless capacity. That means we don't have the problem of the capacity that we need to increase it every time we need to buy new hardware. Then, so we can say we solved the capacity problem. Come the second part, which is the concurrency. Then we have the compute layer. Then we can choose whatever compute size we want. So we can start from X small until 6 XL. We will go in details about how each different category use how much is the computational power for each. And this is like a virtual computing clusters. So we use the clusters technique to do the computing, but at the same time we can choose the different category, and that allow us to do the scalability from storage layer and concurrency from compute layer. Still, we need to enhance and do the optimization, so we start to use the cloud service layer. This is the layer where the optimization take place, where your data governance will take place, and data sharing through the market and stuff. So let's go for the first layer here, where we have the deep dive into micro partition and virtual warehouse. That's what make Snowflake really a fast solution through the micro partitioning. It allows the compression of data, and it do the whole underground structure work for us, so we don't need to use like the old traditional indexing and clustering and semi-clustering to keep our performance fast. That all is done for you automatic. What is really makes Snowflake also special is way of storing the data. It's stored in a columnar format. It means it's like by column it's stored. It's like against what's happening or opposite to what happened in Excel sheet that's stored in a row format. This means if we have some formula we need to apply for a column called revenue and calculate, for example, bonus or something, the formula will be only implemented and touch the data in this column, and that of course save a lot of computational power. Then we have the second most important feature, which is like allow to compress the data into files between 50 and 500 megabytes, and the data, this files is immutable files. It means once we have the first original version from the data, it will never be manipulated. Every time we will do update, we will have a different versions that allow us to do the time travel and zero cloning that save a lot of money. Second most important part is like pruning. So pruning data, this is where we have the metadata allows the query to skip irrelevant file. It means like just remember the old classic class indexing. When you do indexing, you do pruning like a tree, for example, and you just skip. If it's, for example, you choose like 100, you will not go for the value of 10 or 20. You will just go, for example, for above 50, right? And by this way, you do the pruning. Just remember the tree structure, and you can imagine like it happened, but instead of we need to build the indexing on the columns, it's already having the pruning functionality. Then durability, everything is managed by the cloud. You have the resilience and the functionality of the cloud. Storage can happen in a different location to facilitate different copies from the same data, allow you to keep the data alive. So you must remember that also at the end, every time the data will be uploaded to Snowflake, it will cut it into small parts between 50 or small piece between 50 and 500 megabyte cluster. This is the most important and the critical info, and this is how the architect is managed. So let's take this question fast. Which statement is true regarding micro partitioning in Snowflake? The answer will be they are automatically generated and enable metadata driven. So what this mean? It means that Once the metadata have the whole info and the statistical information about our data, for example, the max and the minimum for one column, this data will be used to fit a pruning that is customized to our database. That's why we don't need to create the indexing. Okay, let's go for second part or second layer, which is the virtual warehousing or the computing as they call it sometimes, compute. We have decoupling between the virtual warehouse and the storage. So in all time, you have the like hardware that have the storage and they have at the same time the computational bar. What is happening here? You have decoupling. It means like they separated the virtual warehousing from the storage. So that is actually what make you have this zero cloning facility. It means you can clone the data, and because it's like just referencing to the data where it's stored, it has zero computational power. So we are in the muscle layer where everything important taking place. In this part, you have the you choose the size for your warehouse starting from XS up till 6XL. Every time you double, the performance is doubled, and at the same time the credit amount is doubled. The most important thing, you have two types to scale up the virtual warehouse. To scale the virtual warehouse, you can up or out. Remember, always up, I need to increase the speed for one query. So I will increase the capacity. So I will go from X small to S, from medium to large. Okay? While in a scale out, in this photo, we can see that I will start with adding more clusters. So instead of I have one X small, I have like two X smalls, I have three X smalls. And there is a different way how to scale out. We will talk about it later, but it's important to understand at this time you can increase the computational power or you can add more clusters. It all depends on why you need this. So if you need this for one single query that is large or medium, so primary benefit is scaling a virtual warehouse from medium to large, that we have one large complex query and I need to use the whole computational power at certain point of time. But what if I have like concurrency, several um, like performances needed for several things running parallel, then I need to scale it out, add more clusters. Okay, the last layer is the service layer. In the service layer, we have the data sharing. This is the layer. So even we apply the SQL query in our virtual data warehouse layer or compute layer, as they call it, but the service layer is where we do the optimization for this SQL query. The optimization take place. We apply our data governance. So for example, our data encryption, our rule-based access control will be applied here. Then the data sharing, this marketplace, if we want to share public or private data, metadata tracking. And metadata is like the data statistics about our data we have in our hand. This is the three main layers we have. So the question for this part, which components reside the cloud service layer and decide which micro partition to prune is a query optimizer, and what type of different accounts we have. We have a standard accounts that go for time travel only 1 day. Enterprise and business, it go up to 90 days. This is very important also to know. And multi-cluster warehouses start from the enterprise and business. Materialized view is the same. Materialized view, it's and materialized view allow you a better performance when you have too much complex query on your views. So let's sum it up for today. Our Snowflake is a software as a service platform that allow you to do more flexible operation using the benefit of three-layer data storage in a micro partition, query processing, the compute layer where you do the virtual warehouse, execute your SQL is the muscle of your Snowflake, cloud service is the brain where you have the access control, infrastructure management, metadata, and the query optimization. Next time we will talk about domain 1, 2, and here is the reference for what sources we use today. Wish you a nice evening, and I Hope you enjoyed.